In this video, we're going to be looking at kinetic energy and gravitational potential energy. We'll learn what energy is, and we'll learn about kinetic energy and potential energy, their definitions, and what the equations are to find them. Last, we'll look at how energy can be converted between different forms. Energy is the ability of something to do work or to cause a change. Energy is measured in a unit called joules. It comes in many different forms, including nuclear energy, chemical energy in your food, heat energy in a flame, elastic potential energy in a stretched rubber band, electrical energy, and others, but we're going to be looking specifically at kinetic energy and gravitational potential energy. Kinetic energy is always due to the movement of an object. If an object is moving, it has kinetic energy. It could be a car, a falling apple, or a rolling roller coaster. They all have kinetic energy. How much kinetic energy depends on the object's mass and on its velocity. The equation that relates these together is kinetic energy equals 1/2 times mass times velocity squared. In the equation, kinetic energy is shown by the symbol Ke, and it's measured in the unit joules. M stands for the mass in kilograms, and V stands for the velocity in meters per second. Let's look at a sample problem of how to find kinetic energy. James rolls a 5.9 kilogram bowling ball at a velocity of 8.2 meters per second. What is the ball's kinetic energy measured in joules? We're going to use the Q's process to find the answer. K stands for the knowns, the things that are told in the problem. U stands for the unknown, which is what we're trying to find. E is for equation. S is for substitute or plug in the known values into the equation. And last, S is for solve, showing every step. In the equation, there are several known values. The mass is 5.9 kilograms. The velocity is 8.2 meters per second. The problem tells us the unknown is kinetic energy. That's what we're asked to find. And we know that the kinetic energy equation is Ke equals 1/2 mv squared. Substituting the known values into the equation, we get Ke equals 0.5, which is the same as 1/2, but much easier to put in your calculator, times 5.9 kg times 8.2 meters per second squared. Don't forget to square the velocity. Once we do that square, we have Ke equals 0.5 times 5.9 kg times 67.24 meters squared per second squared. Multiplying those all together gives us an answer of 198.4 kilogram meters squared per second squared. Now the problem asks us to find the kinetic energy in joules. Luckily, that unit of kilogram meters squared per second squared is the same thing as joules. Now we also can use this equation to find the velocity of an object. In this problem, Kevin rolls a 5.4 kilogram bowling ball at 202 joules of energy, and we want to find what is the ball's velocity. Using Q's again, our knowns from the problem, the mass equals 5.4 kilograms. The kinetic energy is 202 joules. The unknown this time is velocity, but we're going to use the same equation, the kinetic energy equation. Substituting in the knowns, we get 202 joules equals 0.5 times 5.4 kilograms times velocity squared. We can divide both sides of the equation by 0.5 and by 5.4 kilograms to move all of the numbers to the left side and isolate our unknown V on the right-hand side. When we do that, we get V squared equaling 74.8 meters squared per second squared. Now to solve for V, we have to take the square root of both sides. I flipped it around here so V is on the left like we're used to seeing, but we're going to do square root of V squared and a square root of 74.8. When we do that, we get V equals 8.6 meters per second. The other kind of energy we're looking at today is gravitational potential energy. And that's energy that an object has due to its position near a massive object, such as the Earth. You can think of gravitational potential energy as being related to the height of an object above the ground or above some other reference point. Anytime something is up high, it has potential energy. Potential energy is also due to an object's mass, just like kinetic energy, but instead of velocity, gravitational potential energy is related to the object's height above the ground or above a reference point. The equation for potential energy, mass equals little g times h. PE is for potential energy measured in joules. M is for mass in kilograms. Little g is the acceleration due to gravity near Earth's surface, and that's always 9.8 meters per second squared. And then height is the height of the object in meters above the ground. Here's a sample problem for gravitational potential energy. Sarah uses a forklift to raise a 42 kilogram box to a height of 2.8 meters above the ground. How many joules of potential energy did Sarah give the box? Using Q's again, we see that we have mass is 42 kilograms according to the problem. The height is 2.8 meters. We're solving for potential energy this time. And we know the equation, PE equals mgh. And substituting our knowns and our constant, we get PE equals 42 kilograms times 9.8 meters per second squared times 2.8 meters. Multiplying all of those together with our calculator, we'll get potential energy equals 1,152.48 kilogram meters squared per second squared. Remember that that unit is equal to a joule. So our answer, 1,152.48 joules. Energy can be converted into different forms, such as potential energy of a ball on top of a hill can turn into kinetic energy as the ball rolls down the hill. But the total amount of energy is conserved. That means it stays the same. In this case, potential energy can become kinetic energy, or kinetic energy can become potential energy. But the change in kinetic energy will always equal the change in potential energy and vice versa, because the total amount of energy is conserved. So as a kid swings back and forth on a swing, they lose potential energy but gain kinetic energy as they swing down. And then as they swing back up, that kinetic energy changes back into the same amount of potential energy. In this lesson, we saw that energy is the ability to do work or cause change. Kinetic energy is energy that's due to the movement of an object, and its equation is kinetic energy equals 1/2 mass times velocity squared. Gravitational potential energy is energy that's due to the position of an object above the ground, and it depends on mass and height in the equation potential energy equals mass times acceleration due to gravity times height. Energy can be converted from kinetic to potential and back, but the amount of kinetic energy that's lost is the same as the amount of potential energy that's gained, and vice versa, because the total amount of energy is conserved.